The following problem can be found in this book on the notation to the right.
Hello, I'm Anthony, and today we'll be doing Part B of question 71. Now, Part B states that if the ramp is now tilted upward so that takeoff angle is 10 degrees above the horizontal, what is the new minimum speed? Basically, instead of a flat ramp, we're going to have a curved ramp that's curved at 10 degrees. Okay, that's so ugly. I'm sorry, let me get closer. There, that's a lot better. The ramp is going to be like this, and it's going to be curved at 10 degrees above the horizontal. It's going to look something like that. All the 20 and the 1.5 will stay the same. That's the only difference. So now that we know that, let's plug in all our variables. Let's see, x initial and y initial still the same. Sorry, it looks like a 9. X final is 20, still 20. Y final is still 1, negative 1.5. And this is where it gets funny, because we're looking for the minimum takeoff speed. Actually, we're looking for the minimum speed, and that now we have this ramp that's angled at 10 degrees. Pretty much, it's gonna be, the x is gonna be cosine, and the y is gonna be sine. So if we do our trigonometry, the initial velocity of x is going to be initial velocity cosine of 10 degrees, and initial velocity of y is going to be initial velocity times sine of 10 degrees. And this is going to be the same as that, same as this, because this is going to be 0, because once it hits the ground it doesn't go in the y direction anymore. This is 0 because constant velocity, and this negative 9.8 because of gravity. The time is unknown. The first thing I would like to do is find time. So I still have too many unknowns here. So this is what I'm gonna do. I'm gonna write out this, but for both. So let's see, initial, I'm gonna do that x direction first. Final is 20 equals, initial x is 0 plus initial velocity is 0, which is initial velocity cosine of 10 degrees times t, plus no acceleration in the x direction, so that part's a big fat 0. And now I'm going to do y over here. The final position of y is, let's separate that. Final position of y is negative 1.5 meters equals initial, that's just going to be 0 again, plus oh god, I'm running out of space, gotta make it smaller, plus initial velocity sine 10 degrees t minus 4.90 t squared. Now I'm going to simplify this one, because it looks like here we're going to have to do a system of equations. Here I'm going to isolate V initial. So if we do some algebra, we're going to end up with, V initial is 20 over cosine of 10 degrees t. Now remember that value. I'm going to insert it on the other side and see what happens. So let's write that all down. negative 1.5 equals, I'm not going to write that again. Remember we said V initial is going to be, just going to write that in parentheses. V initial is going to be 20 over cosine of 10 degrees t times sine of 10 degrees t minus 4.90 t squared. We see here this t and this t will cancel, so we'll be left with negative 1.5 equals 20, let's move that on top, 20 sine of 10 degrees over cosine of 10 degrees minus 4.9. We're only left with 1 t now. Now we're getting somewhere. Sorry, having the sniffles. If we do our math, just do a little here, move this over here, we're going to end up with negative 5.03 equals negative 4.9 t squared. T squared is negative 5.03 over negative 4.4, I can't 4 today, negative 4.90. We square root both sides, we end up with time being 1.0 seconds. That's the answer for time. Now that we know that, let's figure out what the initial velocity is. So I'm going to take the second one, but for y this time. So just write that out, so to check if we all remember, y equals y initial plus v, the velocity of y in the initial velocity in the y direction, times t plus 1/2 acceleration in the y direction times t squared. That's negative 1.5 equals nothing, plus v initial sine of 10 degrees, and we have time now, so let's add that in, times 1.1 second, or 1.0 second, minus 4.90 times 1.0 seconds squared. Do some math. If we do the math, we get negative 1.9 equals, well, we cut that part out, equals v initial sine 10 degrees times 1.0 minus 5.16. Do a little more math, and eventually you end up with v initial equals 3.66 over the sine of 10 degrees times 1.0. Sorry for skipping steps, but you guys should know this by now. It's just algebra, typing it all into the calculator. So if we type that all into the calculator and we round it to two significant figures, we have figured that the initial velocity is 20 meters per second. That is the initial velocity required to jump all of these cars if we added a ramp of 10%. Think about that. Just by increasing the ramp from 0 to 10 degrees, we have reduced the minimum velocity required from 36 to 20. And that sounds like a lot. And thank you for watching. That's all for today.